So now that we've got a really fast way to count k-mers without requiring a lock, let's think a little bit more about our use case. So what we're going to try and do is we're going to count k-mers in a next-gen sequencing or high-throughput sequencing data set, like from an Illumina, for example. And our use case is we're going to discard any k-mer that we only see once. If we've only seen it once, it's probably a sequencing error, so we want to throw it away. So our approach might be to iterate through all k-mers, increment our counter, of course using our lock-free compare and swap method, and then once we've done that, we're going to iterate through all counts and check if a count is equal to 1. And if it is, we're going to delete that k-mer. But we're doing 2 iterations here, and that's really slow. So we'd like to come up with a method where we can just discard the k-mer if we've only seen it once. Well, maybe instead of discarding k-mers, like we're doing here, maybe we won't store k-mers until we know that we've seen them. So thinking about our use case again, in our use case, what we want to do is we want to count k-mers. We want to discard k-mers that we've only seen once. So instead of counting the k-mers, keeping a count of them, and going in and saying, okay, have we seen this one? Have we seen this once? Have we seen this once? We can build 2 data structures. And so we can start by creating a Bloom filter. And remember that a Bloom filter will tell you something is present if it really is, although it may accidentally tell you something's present even though you haven't seen it before, right? But all the Bloom filter can tell you is, yeah, it's present, no, it's not present. So if we start with a Bloom filter, what we can say is we can take a k-mer and we can ask the question, is it in the Bloom filter? If this k-mer is not in the Bloom filter, then we haven't seen it yet. So now we're going to store it in the Bloom filter. If the k-mer is in the Bloom filter, that means we've already seen it once. If we've already seen it once, we want to increment our count. So now we can increment our count. Now, in fact, what we're doing is we're setting our count to 1, but this is the second time that we've seen the k-mer. The first time we don't increment the count, we don't put it in our counter, we just store that in the Bloom filter. The second time we increment our counter. So of course, when we print out how many times we've seen things, when we print out our count, we just need to add 1 for the occasion where it was stored in the Bloom filter and not added to the counter. So what this does is it removes k-mers that only occur once. And it does it in one pass, so we don't have to pass through the data twice. And it does it by using this very memory-efficient data structure called the Bloom filter. There's a slight problem, which is that occasionally the Bloom filter will return a false positive. It will tell us that something's in the data structure when we haven't seen it. So maybe, occasionally, we're going to add a k to the counter when it's only the first pass. But we can change that by changing the size of our Bloom filter array to control the probability that that happens.